Hello everyone and welcome back to the Victoria Game Engine series. This is episode 15 and today we're going to be talking about items, instances and resources. All of these items, if you're wondering what they mean, I'll explain them through the rest of the video. But the first one we're going to be dealing with, the absolute fundamental of them all, is the item. So in core, we're going to create a new folder. I'm going to call it config. And under config, we're going to create item.h. And we'll do our user pragma once and include our type defs when we remember how to type. Like so. An item is the object that we then use to build the rest of our systems on. It has a bunch of base functionality that all objects that part of our, say, all of the stuff that makes up our editor, all of the stuff that makes up our scene classes, so everything that makes your game is going to inherit from item. And that means we need to build it in such a way so that it can have a whole bunch of different functionalities. And we're going to be doing most of those in our video. First things first, we're going to include another thing. There's one thing I've forgotten to include, and that is we need to include core, not typedefs, string, vstring.h, and we can remove that space there. And then in here, I'm going to paste a massive macro and try to explain it through everything at best to my ability. So this is the macro vRegister class. vRegister class, what it does is it takes a class that we're trying to create, the class that it inherits from, and effectively defines a bunch of information about that class. So you can see here, vRegister class has M class and M inherits, and it has a bunch of methods that we want to define constantly from this. The reason we do it this way is because these methods are very repetitive. We need to write them for every single class that derives from item every time we want to use them, and that kind of gets stupid towards the end. First things first, we have get class name, very self-explanatory. Get inherited class name, again, very self-explanatory. We also have static versions of these functions, just because, you know, sometimes you might want to use the non-static version. Sometimes you might want to use a static version. It depends what kind of implementation you're trying to do here. These two functions here, I will explain in a moment. They will be very relevant in a few seconds, but let's leave them for now. After this, we're going to have our next thing to add, and this is going to be an enum, much like our error class. It's going to be a very important enum, and it's going to contain a whole bunch of things, and those are our notifications. So I'm going to paste them as in. Notifications in this context are very different to notifications in the context of our windowing system. Our windowing system may use some that are very similar, but these function differently. The way a notification works is that whenever its notification is called from this list, it will try to do a certain action depending on the implementation. So what I mean by that is that ready, update, physics update, and quit, whenever this node receives any of those functions, it will want to do an action. So for instance, on ready, that will be ready is occurred when all of the objects in your scene tree are set up, and then ready emits. So it would be kind of the last call before the first frame happens. Update would call every frame. Physics update would call every physics update, which can be a lot less than the frame, depending on how the game is rendering. Quit will often happen when the game is attempting to be closed down, so when you press the X on the window and so forth. Notification pre-delete is called whenever the item is about to be deleted. It's going to be freed, all of its data is going to be gone, and it needs to do a certain number of things before that can be done. Enter tree and exit tree will be relevant to our scene tree, so they are whenever that node is added to the scene tree and whenever that node is removed from the scene tree. Notification transform changed is the notification that's emitted whenever the current game object, so objects in our case, as you'll see in later videos, has its position in world space is changed. So it needs to let all of the subclasses know in case they need to update their own transform. And notification visibility changes whenever a geometry instance or like a visual instance needs to change. So for example, if we want to toggle showing a mesh or not notification visibility change will let us know when that mesh is visible and when it's not. And this is important because I'm going to need to explain a couple of things here. In our system, notifications will have two options. Whenever you're creating your own class, your own custom classes, you will have the ability to receive any of these notifications to that class. All of these will be available for you to see. However, all of these notifications do also need to be seen by our own engine classes. And what that means is that we have to find a way to let this notification be seen by both this class and its inherited class. And that is what we are doing with our notification system. And to be honest, this is the only thing I really have for item. Aside from being the base object, it's literally all just this. And I needed to split item and instance for reasons we'll get into in a moment. But I'll now go back and explain these functions. So item get notification, as you will kind of expect, this just returns the function pointer to the class's notification function. So for item class, it doesn't have a custom implementation, so this notification basically does nothing, but we still need that function pointer, so it returns. So notification v is a virtual function. What it means is that it calls the parents class notification function, and then if the current class has a unique notification function, as you'll see from here, it returns the function pointer to the notification function, and you can also check against the parent class's notification function. If they don't point to the same place, this class has a unique notification function that can be called, and the object can do certain things. If that had the word notification in it far too much, don't worry, I agree. Okay, enough waffling about notifications. We're going to now actually write the item class, and I'm going to just drop it in and again do my best to explain. So starting at the top, we have this frame class registry. This is something we're going to be adding in later videos. I'll try to explain it when we actually get to it, but for now you can just ignore it. I've also left it up here. It will be relevant in future. If you know class DB from Godot, again, very similar context, but we will get into that when we do. And the first thing you'll notice is it's more or less just implementing the functions that did exist in this macro, but in the item class. Reason being for this is that, of course, we're not actually using the macro here because item doesn't inherit from everything. Everything else will, so they'll use the macro. But in our case, item doesn't need to worry about any of this, so it will just stay here for now. And of course, we can just define these as is. Item doesn't inherit from anything, so you'll just return an empty string here. Notification doesn't actually need to do anything, as I said earlier. And get notification won't do something. And also, this should be a public function just because of the consistency in our code. That might be something I should update on my end. I don't know why this exists. Notification is always... Okay, I'm getting rid of that. I don't know why that's there. There's some very weird things in these files, but you can ignore that. It should be this. It normally is. It should be this. I don't know why it isn't. That's ridiculous. But we also have notification v here. Again, because that's going to be implemented in pretty much every single extended class. Actually, no. Okay, I'm wrong here. That does need to go there. My bad. All right. Then we actually have our few items that are not just the notification system, except for this one. We have cast 2. This will be something that you will normally want to call. This is something you'll normally call when you're trying to cast an item from its base item class into a higher derived class from item. So what it does here is it checks to see if the object is actually real. It has to be a pointer. And if it is, we try to cast it into that class. Otherwise, return null pointer. And we have a non-const and a const version just in case. Notification here, this notification function in later implementations, when we set up our scene tree and objects, object 3Ds and all that, whenever the propagate notification function is called within the scene tree, it will call to this function. And because it's implemented an item, it will go through every base class. So it will go from item to object to say object 3D to light 3D, and it will do whatever it needs to do there. So for now, this function isn't really being used, but it does serve a purpose a little bit later down the line. And it is how we're kind of meant to interact with notification V. It probably shouldn't be a public function here, but I've set it up as such for now, just in case. And then we have our constructor and our virtual destructor. We need to declare these, even though they don't do anything at the moment, because a virtual destructor is required for classes that have non-virtual derived versions, and also having the constructor is important for other things. With that, all of that said, we can go here, we can create an item.cpp, include from item.h, and we can define our few functions, which you won't be surprised in knowing are just notification, item constructor, and item destructor. And we're going to leave them as is. There's not really a lot to explain here, and we can move on with our lives. Now that we've set up item, it's time to move on to our first derived class, instance. Under config, we're going to go here and we're going to create a class called instance.h. And we're going to do our usual pragma once to include our type defs. We're going to include atomic counter. We're going to include OS, although I don't think this is strictly needed. We're going to include string. And we're going to include item.h as well. So the class instance is going to be pretty small, and I'm just going to put it in here straight up. I'll try to explain everything it does as best I can. I got to change this to UN real quick. Yeah, there we go. So as you can see here, this is the first example of a derived class. We have vRegister class, and it expands to this very hard to read macro, but it's the same functions that we defined here, but defined for this own class. And instances itself does have a couple bits of data. Those are the ref count and the init RC. This is the initialization ref count. I'll get onto that in a moment. Then we have a bunch of functions. So we have ref init, reference, unreferenced, get ref count, is referenced, and the constructor and the destructor, which of course, again, I will get onto. There is a little bit more we need to do in this file, but I'm going to leave that to a little later point because I do want to get some of the functions we need defined first before we move on to doing those. So again, we're going to go to config. We're going to create an instance.cpp. And within that instance.cpp, we're going to include instance.h, and we're going to write a few functions. So the functions are going to be as follows. Again, I just need to change that to uint. This will be something that we address in our 15.1 video, but I'm going to go through these functions fairly quickly. So ref init is a kind of convoluted function. The way it works essentially is we first do a normal reference. By default, when you call to ref init, it expects that you are trying to initialize an object's ref count. So in the case where this is called, there's a very high likelihood that you are calling to an object that has already been initialized and doesn't actually need to do any of the initialization stuff. However, if that is the case, we need to do something. So what it does is it first checks to see if the if referenced value is false. So if the inner RC is equal to 1, i.e. the object hasn't been properly initialized, and it then decrements the ref count, so it unrefs, and if that was successful, then it means that the object can be properly dealt with. It doesn't unreference. The reason for this is normally that ref init is called when the ref count has already been set to 1. It then does a reference, incrementing it to 2, but we need to bring it back down to 1 in order for the ref count to be legitimate. So it does an unreference here because the object has now been initialized. If we didn't do it this way, there'd be problems down the line because of the way that this function is called in code, which again, we'll get to in a moment. The rest of the functions from here, you can pretty much figure out from that function. Reference will increment the ref count. Unreference decrements the ref count. And they both change if you can reference or if the object can die. So if unreference reaches 0, that means that the object isn't being used by anywhere, which means that you can safely kill off this object. Get ref count makes sense. The initialization initializes, of course, and the instance destructor doesn't do anything. There is one thing I should probably mention about instances that I completely forgot to mention when doing an overview of the class. Instances are different from items. They act effectively the same, and there is one pretty significant difference between the two. Instances are items that will have multiple versions of themselves or multiple pointers to themselves referenced across code. In other words, these are our in-engine implementations of smart pointers or unique pointers that any derived class, any editor class we use, system classes in your games will use these functions. Instances in our case are going to be most useful when you dealing with resources, because often resources can be cross-referenced from multiple different source files, and that's a pain to track manually. So in this implementation, we can use this to figure out when we can get rid of our resources when the time comes, and you'll be seeing this used a lot across our code. With that said, we actually need to create the class that our smart pointer is going to use. So the class is called, funnily enough, ref, because instances are ref counted items. So the class is called ref, and it's a reference to this kind of instance. So the class looks like follows, and I will do my best to explain. There's not a lot of documentation on this. That is my fault. I will do my best at some point to do a documentation overhaul. That is something that is definitely due for the code base and will probably be something that happens in one of our mid-episode journeys that we'll be doing. The class ref itself is a template class, so everything has to be in our header file. But it does contain a couple important things. One, contains a pointer to the object that we're dealing with. That's the only thing that this class actually carries. It's only 8 bytes. All good. It does have a bunch of functions that are more or less just the same thing, but I will try to explain my best. So the first thing here is ref pointer. Ref itself is just a ref function, as obvious you can tell. And it just passes another ref object into itself and then calls ref pointer. Ref pointer is also a template function, so it takes the argument in it, and it also takes a pointer to an object to reference, and it does a few checks. Obviously, if it's the same as the current object we're using, return, no point to do anything, and if it's not, then we want to create a ref class, set the reference to be the reference given in, set the internal reference, set our current class's reference to the one that was given to us. And if that isn't null pointer, then we want to call a couple things. So if init has been specified, that means that we need to initialize our object. So we'll make our call to ref init, as you know. And if that call failed, then we set our reference to null pointer. And otherwise, if initialization has been done, then we want to do the same thing, but just to check that referencing works. And of course, if it failed, we set it to null pointer. Outside of that, don't really need to explain a lot of this, because as you'll imagine, it's equivalence operators. So if they're equal or not equal, and they'll specify, if the references are the same, because that's what we're really comparing here. Here we return the reference, or return the reference, or return the reference. Here we make another call to ref if we're assigning from another ref object. You don't actually have to specify T here. And here we're using the move instruction. So this is a new thing, I think, for C. It's a C++17 thing, I think. And that's the move instruction. So what it does is rather than copying data over, which is what we're doing in doing in ref here, instead wants to move the data from the source into here. So it calls to our own unref, so it clears our own data, then manually sets everything up itself. Another note I just remembered that I need to point out here, the reason that we call to our current reference to be a cleanup ref is that when this function goes out of scope, ref's own destructor will call, which we'll get to in a moment, and that will effectively decrement the ref count on the object that it used to be. And that then means if that ref count reaches 0, of course we know that means that the object is able to be killed or cleaned up, so it'll be deleted from memory, set to null pointer, and won't really be interactable. And otherwise, we have other things like casting. So this is why we did item cast to this video. We do actually need to call it here. We want to cast it to the other object that it's using. And because this is normally implied that it's set up, so we call to ref pointer false here. If we want to create a reference from a raw pointer, then we can do that. Instantiate is a very important function. So usually when we're setting up ref counts within our code, we will probably create an object without any arguments, so it doesn't get passed or moved or whatever. We just create a ref count object that doesn't have any data in it, and we need to actually allocate some data to that ref object. So we need to call to instantiate. And if you don't, it doesn't call properly, and you end up having to wonder why you're dealing with a null pointer, and you get a bunch of errors. So of course you call to global new, which sets up a new object with some varargs that have been passed in. Normally, for the most of the objects that I've used refs for, they don't have any arguments. They're normally being set up in importing processes. So you don't really need this, but this is just safe proofing in case anyone wants to make custom classes, and they do need certain objects or arguments to be passed in. We also have a couple of help functions. So we have isValid and isNull. Don't really need to explain these. We also have unref here. Checks if the reference is valid, then unreferences it. And if that reaches 0, then it deletes the ref count. But if not, it just sets the current reference to be null pointer. Because normally unref is called when the object is leaving scope, and that you just want to decrement the ref count and get rid of the reference for yourself, so it doesn't actually try to kill itself over and over, and you do actually end up with a null pointer. It just does it this way for that reason. And then we have the constructors, which more or less just do the same thing as their assignment operators do. Aside from the default one, which actually calls to default, it doesn't do anything. And the destructor, of course, calls to unref. Now that we've done instances, we can move on to the last thing on our agenda in this video, resources. Under IO, because it's going to be an input-output class, we're going to go here. I'm going to create resource.h. And of course, pragma wants include core pipe defs, include core config instance.h. And that's all we're going to need for the moment. And now I'm just going to paste the class, do a very brief explanation. So currently there's only 4 methods the resource class has. As you can see, it's get and set name and get and set path. Now these don't actually do anything at the moment, but I'm not really using these methods. At the moment, resource is just a base class that we'll inherit from, but it will have functionality further down the line. There is, of course, one quick file to create, and that is resource.c++. And we're going to include resource.h. And then there are, of course, the function definitions as follows. Again, nothing really new here, kind of thing we would expect. And honestly, that's pretty much everything this video that we needed to do. Of course, we can do a really quick compile. Okay, so now if we hit compile, it should work. And we have an error. Oh, okay, I see. This just needs to be a size of t. This was something we did in the ref count video, and I think there are a couple other places. If I just look for data size. Oh, okay, there's none here. There was one I missed in that video, and apparently that didn't quite make it onto the repository itself, so that should be fixed now. And if we compile again, we should see that everything compiles properly. And if you remember to switch to launch Linux and then hit run, same as before, everything's working the same, but now we have a couple more classes to play with. So that's going to do it for this video. I know it wasn't the kind of payoff that you might want to hope from a video, but a lot of what we're doing at the moment is a lot of setup so that when we do eventually get to the payoff, we're actually properly set up and we're not trying to implement systems that barely work because we need a whole bunch of other things. We're trying to approach it in a way so that we have all of the foundation, and then when we get to the actually interesting things and we actually make progress, implementing that progress is a lot easier. In terms of what we're going to be doing next in the series, of course, it is episode 15, which means that the next video is going to be 15.1. And in 15.1, I think the plan is to do a whole bunch of code refactoring. The variant class is very out of date. It needs the string in it. It needs array fixed. It doesn't really work very well at all at the moment. So a whole bunch of those things we want to fix. And in addition to that, I did kind of say in this video, but documentation is something that will also be done. But of course, that is something to be done offline. It's not particularly interesting in video format, and I think it's probably best for me to do it offline anyway. Beyond episode 15.1, episode 16 should be some file system stuff. We're going to get our file system set up, and that is mainly because we want to move a lot of the code that exists here out into more customizable systems, and we will be doing that, don't worry. It's just that I want to get the file system down so that we can work on a couple other things, and then we can start moving a lot of this code here into a rendering server and effectively offlining the whole process. So with all that said and done, I do hope you enjoyed watching this video. If you enjoyed it, like, sub, whatever you want to do, and I'll see you in the next video. A bye.